Hello again, math students. Today we're going to stick with Pythagorean theorem one more time, and we're going to be talking about using the Pythagorean theorem, but in 3D kind of shapes, like the kinds of shapes that we were talking about sometimes when we were working on our volume unit. You can see in this picture, I've got a couple of things labeled that we might be talking about in some of our problems, especially on the worksheet today. When we talk about something like a slant height, in a pyramid, the slant height would be the height of one of the faces, the triangle faces. So it's slanted. It's the height of that triangle, but not the height of the entire pyramid. The altitude is what we call the height of the entire pyramid. So it's got to be perpendicular to the base when they draw this in. So you can see in the slant height, I do have a right angle, but that's just for the face. For the altitude, this dashed line that's right here is perpendicular to the base. And then the base is going to be whatever, square or rectangle or whatever we have for the base for that pyramid. When we talk about a diagonal in a shape, I'm not talking about a diagonal necessarily on one of the faces, like on the outside. It would be for this picture, and I know it's difficult to see with a three-dimensional picture-ish on a flat surface here, but I want like the bottom, front, left corner to go to the top, back, right corner. So we're going a diagonal through this entire shape. That's what we're going to be looking at for the most part as we're doing some of these examples today. So for this, and that's what I'm looking for, I am looking for the diagonal that's going from A to G, that's going through the shape. But we're going to split this up, and we have to kind of do it in pieces or in steps. So here's that same picture again. They're calling this a cuboid, which is just another name for a rectangular prism. And I want to find that diagonal. So I want to start by looking at or considering the triangle that's in the bottom. So this would be on the bottom base of this rectangular prism using these two sides, and I'm going to find the diagonal of that face. So that will be the right angle. Now I know it's hard to see the right angle in this, but since this is a rectangular prism, I know the perspective kind of changes a little bit, but this is going to be a right angle. Wow, that wasn't even a good right angle that I just drew right there. So that's a right angle. So the 28 and the 12 are the legs of that triangle. So over here in this yellow triangle, I've got just that triangle drawn with the right angle. So 28 and 12 are my legs. So I would say 28 squared plus 12 squared equals the diagonal, we'll just call that C squared. Now 28 squared, I do not have that one memorized either, so that is 784. 12 squared is 144. Just gonna have to kind of write right over that stuff. So when I add those two, I'm gonna get 928 equals C squared. And then I'll take the square root. Square root, again, we're only worried about the positive answers because these are lengths. So the square root of that answer is going to be 30 point, when I round, 30.5. Okay. To be perfectly honest, when I do this, I really prefer to keep that square root of 928. Because the first step that I'm going to do in my next triangle is I'm going to square that, because that's now going to be one of my legs. And the square root of 928 squared would just be 928. However, I have a feeling that most of you, especially if you're not in person in class today, would feel more comfortable just with that as a decimal number that we can type into our calculator. So this is 30.5. And the next slide, we're going to use that 30.5 along with this 16 to be now looking at the diagonal that's going all the way through the entire shape. So now we've got that 30.5, you can kind of see that triangle is shaded, and I've got it pulled out as a yellow triangle over on the side. The 30.5 and the 16 are my legs. I need to find the hypotenuse, which is then going to be really what I'm looking for, which is segment AG. So in this, now I'm going to have, where can I show this work without writing over everything? 30.5 squared plus 16 squared is going to give me now the diagonal that I actually want. So 30.5 squared is 930.25. You can see now we've got a little bit of an error because it was 928 on the last slide. 16 squared is going to be 256. When I add those, I get 1186.25 equals c squared. And then we'll do square root and square root. So the square root of that answer will be 34.44 something, so it'll be 34.4 for my diagonal. Okay, most of these problems where we're finding a diagonal through a rectangular prism, it's going to be two Pythagorean theorems. First, we have to find the diagonal of one of the bases, and then we use it to find the diagonal through the entire shape. So in this problem, Mr. Wu wants to ship a fishing rod that's 42 inches long to his son. He has a box that's 10 by 10 by 40, and we want to know if the fishing rod will fit into the box. So first I'm going to ask, will it fit flat in the bottom of the box? Because if I can put it in there flat, put some packing material over it, it would be very stable that way. So looking at this, again, I know the perspective is a little bit off, but this is a box. It's a rectangular prism. That means that this would be a right angle. Let me do a little bit better there. That would be a right angle. The 10 that's labeled for the width on the right side would also be the 10 over here. So I would have the 10 and the 40. Again, it doesn't really look like it, but those are my legs. So I would put those in for the length and the width, or the A and the B in this. And then 10 squared and 40 squared, we know those, and we could add those two together to get 1700. And then to solve that, we would take the square root on both sides. Again, only worrying about the positive answer. When I do that, I get about 41.2. Now, if you remember, this fishing rod was 42 inches long. So will that fit in the bottom of the box? And you can't quite read it, but no, it won't fit in the bottom of the box. It's just a little bit too short. So what if we, I don't know why I have more that's hidden down there, but that's okay. If it didn't fit in the bottom of the box, I could look at the diagonal of the entire box, which would be a longer length. And if it was 41.2 inches for the last one, and the rod is only 42 inches, I'm guessing this one's going to work. So we would substitute those in. So we knew that this was 41.2 for this S. And I know that the height here is 10. So when I'm looking for this diagonal, that R is how I label it here. Notice they kept the 1700s, the square root of 1700 from the last slide. This is the way that I prefer to do these problems, because then when I square that, it's back to exactly 1700. If I stuck with that 41.2 and squared that, I would have 1,697.44. So it's off by a little bit. Really, those numbers are pretty close considering how big they are, but this is honestly easier in my opinion. When you add those two together, you get 1,800, and then when we take the square root of that, we're going to get 42.2. Now, remember the fishing rod was only 42 inches long, so yes, it would fit in there diagonally. Okay, take a look at this. This is now a triangular prism. And I want to know the length to go from E to B. To get there, I need to know some other information. So in the bottom part right here, this would have a right angle right there. So the 12 and the 9 are the legs of my right triangle. So I would have 12 squared plus 9 squared equals c squared. We'll just call this c for right now. And then that's 144 plus 81. And when I add 144 and 81, I'm going to get 225, which is actually a perfect square. The square root of that is just going to be 15. So this will be 15. Now I'm going to use that 15 with this height of 8 to be able to find this diagonal. Let's actually call this, instead of a C, let's call it a D for the diagonal of the entire shape. So I've got the 15 and the 8. So I would have 15 squared plus 8 squared equals, we're going to say D squared. So 225 plus 64. 225 plus 64 is 289. We've seen this number before, and actually this is part of a Pythagorean triple. The square root of 289 is 17. So that means that this diagonal would be 17 going through the entire shape. 17 centimeters. All right, we don't want to talk about our labels. All right, for this last one, I want to find the length of the diagonal. This one is going from like the front right corner to the back left corner in the top. And I don't have some of the extra diagonals drawn in that can kind of help us to visualize this. So I think it helps to see this diagonal drawn in. And if we've got 4 centimeters over here, then this would be 4 over here, and this is going to be 3. Now, again, it looks to me like the top angle in this triangle is the right angle, but it's not. Remember, this was a rectangle on the bottom, so this is my right angle right here. And if you've been paying attention to my Pythagorean triples, this is a Pythagorean triple. This is going to be a 3, 4, 5. But that base, let me show you that work. 3 squared plus 4 squared equals c squared. So I would have 9 plus 16, 25. And the square root c is going to be 5. So this length is 5 centimeters. Now using that length with this height, which is 8 centimeters that we know from the other side, that'll help us to find this diagonal. But again, this is my right angle. The 8 and the 5 are my legs. This is not going to be a Pythagorean triple. So 8 squared plus 5 squared equals c squared. 64 and 25. 64 plus 25 is 89. Now, 91 is a perfect square. That would be 9. Or I'm sorry. Oh, I can't. 81. 81 is the perfect square. So this is going to be a little bit more than 9, because that 81 would be 9 if we took the square root. When I do this, so you should be able to get an idea of about how big these answers should be. Oh, and I just messed up in my calculator. This is going to be about 9.4. And this was all measured in centimeters. That diagonal will always be the longest length of any measurement in a rectangular prism. So it had to be longer than the 8. We knew that for sure. Now, today's worksheet has some of these that are diagonals through prisms. Sometimes it's just a right triangle that's in another shape. So you don't always have to double up and do the Pythagorean theorem twice. So be careful as you're working through those. Make sure that you're labeling things and showing your work carefully. Check your answers in school with you when you're done, and then take the learning check. Let me know if you need help.